Hello, my dear students and the rest of the learners. Welcome to part 30 of a 7-part series of tutorials in computer structured programming in C and Pascal. This is section 9 of 13 in the topic data structures. My name is Meme JM, or you can simply call me Emily Swap. In this tutorial, I'm going to look at the data structure called sets. Under sets, I will look at the introduction, sets, how to declare a set type, creating sets, set membership, operations in a set, and how to set comparisons. Let's begin by looking at the introduction to sets. A set is an ordered collection of simple data items. In Pascal, all the elements of a set must be of the same data type. The data type of a set is the same as that of its elements. A set could be of integer, character, or enumerated data type. How do we declare a set type? The type of a set is specified using type definition. Remember, every user-defined data type in Pascal is defined using the reserved one type. A set variable can be declared using a variable declaration. Such a variable represents a set which may contain any member or any number of elements, including none. The maximum number of elements permitted in a set is usually 256. It is defined with the following syntax. Type, set type equals to set of base type. For example, type fruits equals to set of fruits. Set type in this definition defines the name of the set type, while base type is the data type of the elements that can be present in the set. A set cannot be elements of real or structured data type. The declaration of variables of set type is as follows. Variable var set1, set2, etc. up to the last set or up to the last variable of the set type. For example, we can have the following variables, basket1, basket2 of type fruits. The elements of a set have an internal numerical representation like the elements of an enumerated data type. The elements of an integer set are represented by the integers themselves. Character data are given their ASCII code values. Enumerated data are given ordinal numbers starting with 0 based on their position in the type declaration. The manipulation of set elements is done using these ordinal numbers. The following is an example of a set declaration. Type fruits is composed of, this simply means that the data type called fruits is composed of the following elements: apple, banana, peach, pineapple, mango, orange, melon, strawberry. And then fruit set is a set of fruits. Fruit set equals to set of fruits. So whenever you use the word fruit set, we are referring to apple, banana, peach, pineapple, mango, orange, melon, strawberry. We then have variables. basket 1, basket 2 of type fruit set. So when we talk about fruit set, we are referring to the set of fruits. And which are these fruits? Apple, banana, peach, pineapple, mango, orange, melon, strawberry. How do we create sets? Sets may be specified by enclosing the elements of the set within square brackets or their equivalents depending on the implementation. If several consecutive elements have to be specified, a sub-range notation can be used. The following are examples of how this can be done. We call it initialization. For example, we can initialize basket 1 with banana, with mango, banana, and orange. That order is very important. Mango refers to the first element or first subscript. Banana is second subscript. Orange is the third subscript or third element. We can also initialize a variable called basket 2 with the strawberry. We can also initialize basket 3 with nothing. This is called a null set. Then, if we have the variable number, we can have it as variable number, which is set of 0 to 200. This is a statement which not only declares a variable called number, but also tells it what it's supposed to be composed of. So it's supposed to be composed of a set of 0 to 200. The elements of a set are not ordered. So their positions in the set doesn't matter. Let's look at set membership. An element either belongs to a set or it does not. So when you're talking about set membership, we are simply saying that we are looking for elements that belong to a set. If an element does not belong to a set, it's not part of that set. Set membership refers to whether an element is present in a particular set or not. When an element is present in a set, it is said to belong to the set or is a member of a set. Set membership is tested using the in operator. Its result is a Boolean. It's either true or false. For example, in the following example, that is the set basket 1 is mango, banana, orange. The expression in mango in basket 1 returns true because mango is an element of basket 1. While melon in basket 1 returns false because melon is not a member of basket 1. Let's look at what we call operations in a set. So we have the following operations being performed by the following operators. So the first operator, the AND operator, the operation is union, so we call it a union operator. Then we have an intersection operator. We have difference operator. And then with those operations, a union set is a set consisting of all elements in both sets. Union set is a set consisting of all elements in both sets. For example, if you have sets basket 1 initialized as mango, banana, and orange, and basket 2 containing orange and banana, while basket 3 contains mango and orange, then if we were to add or we were to unite, the content of basket 1 to those on basket 2, I repeat, let me read this statement the way it's supposed to be read. This statement means that get mango, banana, orange, and melon, and make them members of basket 1 and basket 2. In other words, basket 1 plus basket 2. Remember, I'm taking my time, my dear students, and the rest of the learners. Remember, this operator is called union. This operator is called union. So you are joining elements of two sets. So if you add the elements of basket 1, basket 2 to the elements of basket 2, what you get is the overall result of all the members or all the elements in that set. So if we have a statement like this one, where we are talking about basket 1 being united to basket 2, simply what we expect is to get a new union or a basket is to get a set that contains all the elements contained in basket 1 and basket 2. But what are we doing with this statement? We are picking the elements called mango, banana, and orange, which belong to basket 1, and we are adding to melon. So in other words, we are just adding. Remember, basket 1 contains mango, banana, and orange. Basket 2 contains orange and melon. So when we are uniting the two sets, you don't repeat orange again. Remember, orange is in both. And therefore, when we add set 1 called basket 1 to set 2 called basket 2, what we get are the overall members of those sets, are overall elements of the set. And these elements are what? Mango, banana, and orange. Or mango, banana, which is purely in basket 1. And then we have orange, which is in both baskets, and melon, which is in basket 2. So we get mango, banana, orange, and melon. We don't duplicate. So we cannot have it as mango, banana, orange, melon. No. Intersection set is the set that contains all the elements common to both the sets. For example, basket 1 and basket 2. Remember, this is not multiplication, my dear students and the rest of the learners. Remember, I have already said that this operator is called intersection operator. This is intersection operator. So it looks for that element or that member who is not in both, or who is that member who is in both sets. It picks that member who is in several sets. So intersection set is the set that contains all the elements common to both the sets. For example, the only common member of basket 1 and basket 2, as you can see here, the only member who is common here in basket 1 and basket 2 is orange. And therefore, the intersection set will return orange. So this statement is asking, who is common? Who is in both basket 1 and basket 2? Whoever is in both basket 1 and basket 2, that is who we generate as our intersection set is the one who we write. So in this case, it's orange. Difference set is a set that contains all the elements present in the first set and not present in the second set. That's called difference set. For example, this statement reads as follows. This statement reads as follows. Who is in basket 1 that is missing in basket 2? Who is in basket 1 that is missing in basket 2? Let's see. Who is in basket 1 but is missing in basket 2? Basket 2 has orange and melon. Basket 1 has mango, banana, and orange. So who is in basket 1 but is not in basket 2? So whoever is in basket 1 and is not in basket 2, that is who will form our new set. So who is missing? The one who is common is orange. But who is missing in basket 2? Basket 2 is missing mango and banana. So let's see. So you can see the answer is mango and banana. So mango and banana is our difference set. Is our difference set. The above operations are performed only on sets of the same type. Let's now look at set comparisons. Sets can be compared using relational operators, and these comparisons return a Boolean type. It is either true or not true, true or false. However, the sets compared must be of the same type. So let's look at the operators that we use and example. So the first operator is called equality operator. So it means set equality. So example is basket 1 equal to basket 2. In other words, are the elements in basket 1 the same as those in basket 2? The answer is false, not true. Then set this other operator is called inequality operator. So it means set inequality. For example, is the set from basket 1 is a set from basket 1 not equal to basket 2 or the elements in basket 2. I repeat, is the set of elements from basket 1 not equal to those of basket 2? Yes. So the answer is true. They are not equal. Then we have this other operator. We call it inclusion of left operator. So it means set inclusion of left. So basket 1 or basket 2, set inclusion of basket 1, set inclusion of basket 1. So what will be the answer? The answer is false. My dear students and the rest of the learners, this is very important operator to remember just like the others. So it finds out whether the content of basket 1 is equal to those of basket 2 and, or in other words, let me put it in a better way. This operator checks whether the content of basket 1 are less than or equal to those of basket 2. I repeat, This operator and this expression simply means check whether the content of basket 1 is less than or equal to the contents of basket 2. So are the contents of basket 1 less than or equal to those on basket 2? No. So that is false. This is because the content of basket 1 are not equal to those on basket 2. And they are not even less than those on basket 2, because basket 1 contains how many elements? That's what we are saying. If we go back to those sets, you can see that basket 1 contains 3 items or 3 members. Basket 2 contains 2 members. So basket 1 is not less than basket 2. In other words, the number of elements or the number of members of basket 1 are not less than those of basket 2. And at the same time, the content of basket 1 is not the same as the content of basket 2. Otherwise, basket 2 contains oranges and melons. Basket 1 contains mango, banana, and orange. So they are not the same. So basket 1 is not less than basket 2, nor is it equal to basket 2. So that's what we mean, my dear students and the rest of the learners. So we move on to the next. The next operator is the same one, but now it can also read as set in right set. Set in right set. For example, the content, this statement reads as the content of basket 3, the content of basket 1, the content of basket 1, the content of basket 1, are not less than or equal to, I repeat, I'm taking time, my dear students, so that you can also know how we read these statements. First of all, have a look at basket 1 and 3. Here is our basket 1. It contains mango, banana, and oranges. Here is basket 3. It consists of mango and orange. So to begin with, the content in the set basket 3 is the same as the content of the members of basket 1, but basket 3 has less of the members than those of basket 1. So basket 3, set 3 is less or contains less number of members than those in basket 1 set. And at the same time, the members of basket 2 are also found in basket, the members of basket 3 are also found in basket 1. And therefore, this statement here, this statement will return to true. Are the contents of basket 3 less than or equal to the contents of basket 1? Yes, that is true. This other operator is for setting inclusion of right. So it means set inclusion of right. Set inclusion of right. So are the members of basket 1 set greater than or equal to the members of basket 2? Are the members of basket 1 greater or equal to the members of basket 2? My dear students and the rest of the learners, kindly compare this statement with this statement so that you avoid interpreting them in the same manner. Let's go to basket 1 and basket 2 and see what they contain. Here is our basket 1. These are our baskets. This is our basket 1, and this is our basket 2. So, how do you compare the two? We can see that the members of the set called basket 1 are more than those of basket 2. But those of basket 2 are not more, nor are they equal to those of basket 1. And therefore, when we are reading these two statements here, set inclusion of left, set inclusion of left. This statement is basket 1 less than or equals to basket 2. Simply, it is saying that the content of basket 1 are less than or equal to the content of basket 2. The content of basket 1 are less than or equal to content of basket 2. That is false. Content of basket 1 are not equal to the content of basket 2. So, content of this statement is content of basket 1, members of basket 1 are equal to the members of basket 2, or the set called basket 1 is less than or equal to the set called basket 2. That's not true. After all, it is the opposite. But when we move to set inclusion of right, set inclusion of right, it's almost similar to this other one. But then this one means that the content of basket 2, the content of basket 2 are more or equal to the content of basket 1. I repeat, the content of basket 2 are more or equal to the content of basket 1. In other words, basket 2 is having more members than those of basket 1 or equal members. So the answer is false. The answer is false. Let's have a recap of these operators. So the first one is set equality. So we can read this statement also as follows, that basket 1 contains the same or equal, the same and equal, or basket 1 contains the same members as those of basket 2. Basket 1 contains the same members, or set 1 contains members, the same members, the exact same members are those members of basket 2. The answer is false. Why false? Because we have a member in basket 2 who is not in basket 1, and that member is orange. Therefore, this operation, this comparison, when you compare basket 1 to basket 2, the answer becomes false. They are not the same. Then this other one, you are comparing basket 1 with basket 2. So this statement is saying that the members of basket 1 are not equal to the members of basket 2. So basket 1 is not equal to basket 2. Set called basket 1 is not equal to set called basket 2. That is true. And then we move to this other operation. This operation means that the content of basket 1 are less than or equal to the content of basket 2. That is false. They are not, because basket 1 has 3, basket 2 has 2. Then this other one means that the content of basket 3, the content of basket 3 are less than or equal to those of basket 1. That is true. That is true. Because basket 3, as we have seen, contains 2 members. And of course, those members are the same members that in basket 1. But basket 1 has 3 members, while basket 3 has 2. And therefore, the expression basket 3 is less than or equal to basket 1 is true. Then this operation is supposed to be then, because it said inclusion of right. It simply says, it simply states that the content of basket 2 are more or are greater or equal to the content of basket 1. That is false. After all, basket 2 contains only 2, and basket 1 contains 3. And those 2 are not even the same as those in basket 1, so it is false. Then we have set in left set. Set in left set. What does it do? Like this expression, it says that basket 1 is greater than or equal to basket 3. In other words, it states that the elements of basket 1, are more or equal to those on basket 3. That is true. So these operations can be interpreted also as follows. This expression is saying that the content of set called basket 1 are fewer or equal to those of basket 2. That is false. This other one is saying that the content of basket 3 are less than or equal to those of basket 1, which is true. Then this other one means that the content of basket 1 are less than those of basket 2. In other words, it states that the contents of basket 2 are more or equal than those of basket 1. That is false. Then this other one means that the content of basket 1 are more or equal to those of basket 3. It is true, they are more. 2 sets are said to be equal if the same elements are present in both the sets. That is, both are completely identical. When no elements of one set are present within another set, the first set is said to be contained in the second set, or it's a subset of the second set. The condition of set inclusion is satisfied. So the expression set 1 is less than or equal to set 2 simply checks if set 1 is contained in set 2. It checks if set 1 is contained in set 2. And set 1 greater than or equal to set 2. Remember, the less than or equal to and the greater than or equal to here is not meaning the same thing as it is used to mean in the normal operations. In sets, kindly note the difference. So set inclusion of set 2 checks if set 1 contains set 2. Set 1 contains set 2. That is, if set 2 is contained in set 1. And with that, My dear students and the rest of the learners, we have come to the end of section 9 of this topic on data structures. You can continue to section 10 of 13 in this topic in the next part of this series of presentations. Congratulations for learning section 9 of 13 in the topic data structures. You can also access section 1 to 13 of this topic, other topics in the computer structure and programming unit, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. You can also visit MLSWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in the next part of this series so that we can learn more about data structures. God bless.